multiplication primarily. Okay, so here's what a vector is. It's a very big deal in physics because so many things can be represented with vectors. Vectors basically have two things. They have a magnitude, okay, and they have a direction. Why is that a big deal in physics? Okay, a force. A force can be written as a vector. It has a magnitude. Usually it's in newtons, like 50 newtons. It has a direction. Gravity, the direction is this way, right? Okay, so there's always some sort of direction to that. So that's why it's such a big deal in physics. So you have those two things. Our textbook, which I don't like, that they use a boldface type for a vector. Most of the time you'll see me write it like this, just a V with an arrow on top. Some textbooks do V with a hat on top, okay? The most common one you're going to see is the arrow, so that's the one that I'm going to use on that most of the time. So what I want to show you on this is just kind of what a vector is. A vector basically just has a magnitude and a direction. So in this diagram right here that I gave for you, there's 4 vectors here. They have a certain length and they have a certain magnitude to it like this. So what we're going to do is we're going to take these 4 vectors and we're going to do vector operations to them. So I'm going to show you, just kind of introduce you to that idea today. Okay, what I want you to do is we're going to do u plus z on this blank graph right here. And vector u, I'm just going to write a note to myself to help you do this. This one basically has 1, 2, 3, 4, 5. Vector u is just going to the right 5. Okay, that'll help me to draw that vector out. If you look at vector z, that vector is just going up 1, 2, 3, 4, 5 units. So it's like that. So we're going to draw out that vector, and then I'll show you what it means to add vectors. In physics, you can add forces, okay? You can have 2 different forces acting on an object, and when you add forces, that's the net force of that. So what we want to do on this is, first of all, let's start just by drawing a vector u down here somewhere. So all you got to do is just start with like a dot somewhere, and then you go to the right 5. So you go 1, 2, 3, 4, 5, and then you draw that like that, and that's going to be your vector u like that, okay? Now what you want to do is we do this, when we're dealing with vectors, we do kind of a tip-to-tip form of this like this. So what I'm going to do is that z, you want to start it at the end of u. And vector z is just telling you to go up 5. So we'll do this. We just start there. We go 1, 2, 3, 4, 5 up like that. And then that represents the vector z like that. Now what I'm going to show you is a tip-to-tip form, because to me that's the one that students understand the most. So when you add vectors, all it really says is you're starting there and your journey ends there. So the net force would be the vector going from there to there. So all you do is connect that beginning to that end, and then you've got what that vector sum is represented by. Okay, so we just do that. Okay, and then you label that as u plus z like that. That's what it is. You put one tip on the end of another tip, and then that gives you that vector force like that. Okay, all right. So what this would kind of mean, and you can tell me if this makes any sense or not, like if you had a pool ball, if you play pool, if somebody hit the pool ball that way and somebody hit it that way, does it make sense that the direction would go like that? Okay, that's what it is. Okay, that's what a net force of a vector is showing you. Okay, all right, let's do the next one. W, I'm going to look at my diagram up here, and this has a slope to it. So it looks like that is going down 1, 2, 3, 4. It's going down 4, and it's going to the right 1, 2, 3 like that. So down 4, right 3. I'll write that note to myself so we can write that out. Now what we want to do on this one is we're doing 3 times that vector. Okay, so you can take vectors and you can multiply. We call that scalar multiplication. So let's start up here. Put your beginning there and just go down 1, 2, 3, 4, and over 3 like that. Okay, and let's label that as vector W. Okay, remember a vector has a magnitude and it has a direction to it. Okay, the direction's kind of southeast. It's like the slope. So really all we do on this, if we multiply that by 3, what we're going to do is we're just going to start here and we're going to just do the same thing again. We just go down 1, 2, 3, 4 over 3 like that. Okay, and then this vector right here that whole vector would just become 2w, like that. Then if you do it one more time, from that point, if you go down 4, 1, 2, 3, 4 over 3, then you're going to have that. So that whole vector like this, that resultant would be 3w like that. Okay? We call that scalar multiplication whenever you multiply a vector like that. Okay? All right, does that make sense to everybody? Okay? All right, so we got to kind of get the geometry down with vectors before we do much with it like that. So let's finish up with just one more. Let's do the v minus w. Okay, and I'm going to go back to the v here, and I'm going to write down what v is. It looks like v is up to right 4. So v is up to right 4. Okay, and let's see, w is down 4 right 3. Okay, so let me kind of show you what you do with this, then we'll finish up with this example. First of all, when you're doing vector subtraction, you just change this to v plus negative w. And that negative just changes the direction of the vector to backwards. So it just changes the direction. So what we want to do on this is we can start kind of somewhere in the middle here. So let's just kind of start with vector v. Vector v, pick a starting point in the middle somewhere, and let's just say there, and then you're going to go up to right 4 like that. 1, 2, 3, 4, and then you can sketch out that vector like that. So that will be your vector that we'll locate as v like that. Okay? Now, what you're doing on vector w is vector w is down 4 right 3. I do want you to go ahead and do that right now. So I'm going to go from the tip of that, I'm going to go down 1, 2, 3, 4, and 1, 2, 3 over like that. Okay? And then we'll label that as vector w like that. Okay, but what we're doing is we're not doing that resultant. See, if we were doing v plus w would be the vector from there to there, right? What we're going to do is change the direction of that. So it's just like doing the opposite of the direction. So actually this would just be now up 4 and to the left 3. Okay, so what I'm going to do on that is let's go at the tip of that vector v, and now let's just go up 4, 1, 2, 3, 4, and then to the left 3. 1, 2, 3 like that. And then this will be your vector negative w. We just changed the direction. Okay, now what's the answer to this problem? It's just from the beginning of your journey to the end of your journey. That's your vector right there. Okay, that's what that is. Okay? All right, so your final answer would be this vector from there to there. Okay, like that. Okay? So you can label that as v minus w. All right, so that's what we do with vectors. And again, this is a real big deal. If you're going to study engineering or science and stuff like that, vectors are going to be a very big deal to you. Okay? All right, so that'll wrap us up for today.